All right, let's have some fun doing a demo program. Let's go talk to Sandra. We're gonna have Sandra help us out. All right. Hi, Sandra. How are you today? Oh, yeah. Sandra,
Hey
how are you
there.
today?
No worries if there's something specific on your mind or anything you want to chat about. I'm all ears.
Okay. Well, I asked how you're doing today.
Oh, I'm doing great. Thanks for asking. Just here, ready to help out and chat with you. How about you? How's your day going?
It's going great. I'm here with my students, and we are working on some programming scenarios for uh, what was it that we're working? Functions. We're doing functions. And oh, and remember last time I asked you to do some problems for me? You got it wrong. I'm asking for the scenarios, the problem scenarios. So what I would like is three programming scenario problems that are for students learning about functions for the first time. The scenarios need to use a value that returns and two arguments, or just multiple arguments and returns a value. And yeah,
Got
got
All
it.
right, let's All right, awesome. I'll put together three scenarios that involve functions with multiple arguments and return values. Let's make them fun and practical for your students.
Oh yeah, definitely fun. Let's do that. Okay, so when I go off live, I'm gonna let you know when I'm ready. Okay.
Sounds like a plan. Just give me a shout whenever you're ready and we can dive right into those scenarios.
Great.
Looking forward to it.
Great. Thank you. I think my old chat was in there. Oh, let's jam. Yeah. Oh, she always hits me with the best ones first. Alien language analyzer. Oh, we so got to do that. Oh, yes, definitely. String of alien gibberish. A function to count how many uppercase letters, count how many digits, count how many special characters, non-alphanumeric outputs. The counts labeled clearly. Okay, guys, this is great. And you know what? We're going to build these functions ourselves. They actually already they have pre-built functions that will detect uppercase letters and digits, but we're going to build those ourselves. Uh, yeah, this is going to be great. All right, let's get into it. Sandra, you are so good at this. Oh my goodness. Dang. Sandra, you're off the hook. Awesome. Alien gibberish. I love it. Okay. All right. It's time to write some code. All right. We need, okay. Oh, you know what? This is beautiful. Inputs, processes, outputs. We already got an IPO chart. So I'm going to ask for a string called gib, gibbs, or just gib, and I'm just gonna initialize it. That is what we're gonna do a CN of. And we will do an output, say enter your alien. Uh, gibberish. I don't know. Enter your gibberish. That's fine. I don't want to get too, because I tried it. Yeah, let's roll. Okay, uppercase letters. All right, let's do this one first. You notice I'm going to the very top for our development. Now, usually what this is called is a what the way these work is they return a boolean, and you use them within if statements to process a string. Now, I'm always really kind of big on get your memory, print your memory. In this case, the memory that we have is CN, the gibberish, but here's the thing. We have to process every character in this gibberish. So how are we going to do that? Well, there is a function called at that will output a specific index of a string. And I think actually let's do that first, because that's we're going to be sending every character in the gibberish string to these functions to determine if it's an uppercase, a digit, or a special character. So that means I shouldn't be doing anything until I know how to get things and process just those single characters. So that's get your memory, print your memory. So let's process those single characters. So I'm going to do a for loop that's equal to 0, and it's going to be less than the gibberish's length. Now that's a function, so we got to put, I think it's a function. I could be wrong. It could be a property. We'll find out. I mean, every language does length differently, and I always forget. So what this gib.length is how many characters are in the string. And so I need a loop that loops through and looks at each character, and so that I can examine the character and determine if it's uppercase or whatnot. And here what we want to do is we just want to go through each character in the string and print them. And we're going to do that with a subscript operator. Now, we haven't gotten into arrays yet, so this is kind of a little bit of a preview into arrays, because every string is an array of characters, chars. We call them chars. And we can access those read and write privileges using the at function. No, I think it's only at is only read. So what at does is we send it the index we want of the string itself. So this E would be at index 0. The N would be at index 1. The T would be at index 2. And so we're saying, I want the character at index 0. Then I want the character at index 1 of the gib string. So let's look at what it does. Okay, I just inputted it, and then after I input the CN line ran, and now the debugging is now down to here for the runtime. So we're looking at I. Let's do this. We can look at gib, and we can see the size is 1 here. Capacity. No, I don't know. Something may be off about this. Oh, I know what it is. Yeah. Okay. This makes sense because CN can't handle spaces. So there the example of gibberish, we are not allowed to put spaces in them. All right, so you can use cn.getLine to get beyond that. I don't want to get too deep into things that you guys don't know. I've introduced enough. Let's just enter in the gibberish as one line. I will eat you. Good. Okay. Notice I didn't do any spaces there. So you see down here in the I will eat you gibberish, the size is 11. We could actually look at, and then look, location 0 is the I, location 1 is the W. Okay, so when we print out that first one, gib at I of 0, we get the I letter, I. Okay, and then it just continues through the loop for the length of the string. And this is designed where length, you don't have to do length minus 1 or anything. It's designed as long as you're doing less than, you can just use length. And you don't have to do length minus 1 or plus 1 because you start it at 0 or at 1. And so that's another reason why, because everything is 0 based in programming. Okay, so then we go and we've got this next little output. Great. And we got boop, 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 done. All right, let's take off this breakpoint. Let's hit continue and it will finish. There we go. So I will eat you. Okay, so let's make a few little improvements here on the user interface. What we want now is we've got our memory, we've printed our memory. We have the little pieces that we're going to send to the uppercase letter. Uppercase letters. All right. And we're going to use the char data type. I believe we're going to use the char. Well, we have to because we're going to be using an ASCII code. So we're going to have a function that returns Boolean is upper. Very simple. Let's do this as J is upper because I think is upper is already taken somewhere. J is upper. Okay. Oh, that kind of looks weird. Is upper. Let's do it as uppercase. That would be enough difference from anything that else is happening in libraries. Okay, so that, by the way, this function is already built for you. It's in the library. I want to show you how it's built because it's fun. Okay, what are we doing? We're sending in a char. Is that what this is? What is at return? Well, let's go look at that. Let's go look at the function, C++ function at. Oh, let's ask Sandra. Nah. Oh no. Whoa, my Chrome just died. C++ at function. What does it return? Does it return a char? It's a reference to a char, so we may need to do some conversions to get it to an actual char. Oh no, it's a char. See that single quotes, that's assigning char, and it looks like it's a mutator as well. It allows you to change string. Most languages don't allow you to change strings at all. They don't allow you to have write privileges to it. Thank you, C++. I'm glad you're not stupid. Okay. Is uppercase. Well, fan of get your memory, print your name memory. Char ch, that's what we're going to be passing. Because at returns a char from the string. So remember, a char is just a single E or an N. And what a char is and how it's coded comes from something that we have already looked at before. Dun, da, da, da. ASCII code chart. Okay, this is actually how we're going to do the job. Because what we can do is, if it's a char, then it maps to this ASCII code chart. All chars do. In fact, you only have 128 characters. I'm using chars as a keyword, but characters. This is how they're stored with these decimal numbers. So a capital A has the value 65. So if we want to know it's a capital number, we just need to convert it to this number and have an if statement that says, hey, if the integral value of the character is between 65 and 90, it's an uppercase. Done. Yeah, it's that easy. So what we can do here is let's just output. Let's just output for fun what are we going to output? I just lost my train of thought. The integral value of CH. So then what we do is we take CH, and if I'm being old school, I would do something like this. We might have to do a conversion formula. I don't know if it can handle it. That's old school static cast. I always do it old school, so I've never really kind of got the... Yeah, let's do it right. Let's do C++ static cast. I always forget this stuff. Oh, okay. Where's the example of you? Where are you at? Where are you at? There we go. Yeah, all right. Okay, so it used to be just, you would do this. In fact, let's do it both ways. And then let's do a cout, a space in between them. And so what we're going to do is here, we're going to send the function is uppercase Now we're going to get an error. In this case, this is my argument. You see how easy it is when you kind of go with that get my memory, print my memory idea? So, you know, extend that with what you're working on, because it's always good to just print what you're going to process. You can't process it unless you have it, and you can't have it unless you're in the proper scope with it. And you can't have it if you don't do it or send it in functions properly or declare the variable at the right scope. I call it hooking up. That's what I call it, hooking up your variables, getting them talking to each other. So what is this going to do? It's going to run is uppercase multiple times. Now you notice that we're not getting a Boolean. We're just kind of silently ignoring it. I don't know if it'll work. Let's see. It's been a while. Yeah, right there. Must return a value. Okay. Return. We're going to just return true for now, because we're just give my memory, print my memory. Okay, let's see if we can. Okay, it does work. We don't have to actually catch the bool that we return, because you notice I'm not setting is uppercase equal to anything. So if I were to do this properly, in fact, let's just show you it properly. Bool answer equals false. Okay, I'm using false, but you guys all know it's 0. Okay, and then what we'll do is we'll assign answer to it. And that's how we catch the answer that is returned here. Okay, so let's look at this. I will eat you. Okay, there we are, right here. We're going to pass in the character I'm going to do step into. Okay. We're going to convert ch to an integer, the character to its integer, and that's an I. Now you see right here, the 73, it even shows you its integral value. Let's look at capital I. Look at that, capital I, 73. It shows you the integral value. We convert it with old school C, and then we return true. Now, when we are converting this, what we're doing is we're just outputting it. We convert it and then output it. That's all we're doing. We're not doing anything else. Then we return just kind of a true to it, just to have something. And then it continues on. And it'll keep going for every character. So I'm just going to hit continue. And let's look at our output. Okay, so the first one was value 73. Then it was a 119. That means it was a lowercase. If you look at the ASCII character code, we see here 119. Oh, why are you doing this? All right. 119 is a W. I will eat you. Okay, enough of that. Enough of that. Yeah, it's too much. Too much. All right. So we have our memory. In fact, we have what we need to process on. Let's do this properly with the static cast. So the way this changes with the static cast is you tell it to cast it, and you tell it what data type to cast it to, and then you send it what you want to be casted. And it converts it for you. It'll convert it to its integral value. Because a char is just an int. It's just an integer. But we treat it differently because we're assigning an integer to that character, and on the screen, on the standard output, it needs to show as an uppercase A or whatever. Even though it truly is an integer, just like true and false, 0 and 1. True is a 1, false is a 0. So it's a nice little convention, but we have to go back and forth before we can process things. We can now process that character. We can order it. We can order it alphabetically. And when you alphabetize, you sort things based on its on the alphabet. You're actually sorting it based on the ASCII code. That's why anybody that has a number in their name always goes to the top of the list of any kind of portal, whatever. Or any kind of name that you sort, is because these have a lower value. You see the capital A has a lower value and the lowercase a has a lower value. Before you sort, you might want to convert it to all lowercase and then you sort it. Okay, so now let's just run this through, make sure it runs without debugging. I have a death ray. Okay, there we go. Now it's time for our logic. All right, that means then we're going to say if the value that's been converted into an integer now, what are we looking for? Is it uppercase? So that means if it's, and I'm going to refer to this over here so that we can look at the screen. If it's a capital A, it's going to have the value 65 to 88. So I'm going to say if that is greater than 64. You could do greater equals to 65. I imagine that's probably better. Let's do it that way. And so we're using an and. It's inclusive. We got to see if it's in that band, capital A through capital Z. And it needs to be less than. And that's our data that we're processing. Get your memory, print your memory. If that is, what are we doing here? Less than 90. What? Yeah, less than 90? Yeah, less than or equal to 90. Then we return true. And we're only going to do a one-liner, or I'm not going to do any squigglies. If it gets beyond this if statement, if it returns true, it'll never get to this guy. So we just lazily return false there. Because only if this trips will it return true. And if it returns true here, that means it comes out of the function immediately and never runs this line. But if it never gets inside of the scope of this if statement, and remember the first line, if you only have a one line, then that means you don't need the squigglies. So that would be like, you know, that would be this would be kind of the way that you would do it. It's just shorthand, it's lazy. So if it ever got inside of here, it would return true and not get to here. But if it never got inside and it just went right down to here, then it's appropriately false. So that's just being lazy. That's all. By the way, here's the thing about programming and being lazy. There's kind of a saying out there that programming is like chess. Everything is perfect until you move a piece. In programming, everything is perfect until you write a line of code. So the more you move a chess piece, the worse the things get. The more lines of code, the more things that can go wrong. So if you have less code that solves the problem, it's faster and there's less code to maintain and make sure it's correct. It doesn't mess up. All right, let's test this. Now here's what we're going to do is instead of answer equals, we're going to run this function, but the return is going to be injected into an if statement. Okay? All right. I'm going to enter in 3 uppercase. No, I'm going to enter in 2 uppercase and 1 lowercase. Oh, I'm what am I doing? Come on. Okay, the first one is an upper, the second one is a lower, and the third one is an upper. Okay, so we got 3 in there. Now this first one that we're going to look at, we're going to, the if statement's looking at the return of the function being run. If this is confusing to you, then do this. Okay, if that's easier to follow, that's essentially what we're doing. But why even have an answer if the if statement only cares about a Boolean and the function's returning a Boolean? Let's run the function first, because guess what? The function has the highest precedence. The function call has the highest precedence in operator precedence and associativity. The parenthesis characters and everything. So it's evaluated first, and so we're lazy. Let's be lazy. Why even have it? That's just more crap. Let's have less crap. But while you're learning, I recommend going and doing that sort of thing, just so you can kind of understand all the little pieces and where everything kind of goes and everything. Because it can be daunting and overwhelming. It really can. I mean, when I was learning programming, I really did a deep dive, and I would spend hours and hours every day just C++. And it took me several years before I got confident with it. It was hard for me. So be prepared for some hours, especially if this is going to be your profession. And also, it's kind of fun. I'm getting off topic. I need to get back on topic. I apologize. So let's debug. Let's look at this. What are you doing? Oh my goodness. I was already running. I forgot. Okay, I don't know. Yeah, I got off on a side topic. I need to stop that. Okay. There we go. Let's step into. The first one is a capital I. Good. Okay. Now, is that value 73? Is it greater than or equal to 65 and less than or equal to 90? And that's what, and you can just do this. Just do just add that into your watch. Go and add a watch to it. Okay. See right here, static cast, int, ch, 73 is what it returns. So what the if statement is is evaluating is first, it's evaluating $73 after it converts, which has a higher precedence in associativity. Then it compares these, and then that's when it goes to true or false. Look at that. Kind of, I highlighted it and popped up as true. Isn't that cool? Yeah. Okay. Okay, and then it's going to return true, and then I is upper. Okay, and that's kind of how it works. Now the next time it goes through, this is when we have a lowercase. I believe it's a lowercase. Let's look at it. Yeah, it's an H. It's a lowercase h. It has the value of 104, which means it fails this. So it skips that, and then it goes right to return false. And then that doesn't happen. Okay. So how do we do this when we're trying to count how many uppercase characters there are? Well, it would help to have a variable that counts it. Number of uppers equals 0. This is going to be an accumulator. So every time that it is upper, and I'm going to do this for clarity, every time that it's an uppercase, we just say nuppers is equal to nuppers plus 1. Or let's just be lazy, nuppers plus plus. Otherwise, we don't iterate how many uppercase characters there are. Then when that's done running, we can just say cout number of uppercase is, and then here we would do nuppers. Let's do an end line. Okay, now this is the beautiful thing about programming is once you solve a little bit, it kind of balloons up like a snowball rolling down a hill. And before you know it, you have this massive code and every bit builds on each other. We now have this tool that we've built. Now we can just kind of extend it. Okay, what is the next one we got to do? Come on, Sandra, where are we at? How many digits is digit? So we want an is digit. Okay, so what is a digit? A digit is a number like 0, 1, 2, and it's going to be between 48 and 57. 48, 57. Whoop, whoop. Okay, so done. Snowball, here we go. What's the next one? Let's do it. Special characters. Ooh, that might be a turd. What are we going to consider special characters? Ooh, it is a turd. That one's a hard one. Not really. We can do it. Yeah, that one will be fun. That one will be fun. Let's do that. Okay, so I don't know what we're going to call special characters in the ASCII code chart. But I'm thinking, just for fun, let's count these guys, all these guys, these guys, these guys, and these guys. So we're going to be using a lot of ors in there. And it's just going to be an extension. So how is that going to work? All right, let's do the first span. And what it's going to be, the first span is between 33 and 47. All right, so now we're going to get complicated because we have another set of special characters with the integral value of 60 to 64. So in this case, we're going to take this whole thing and let's just space this out so we know what's what. This is the if statement. This is our first possible comparison. And then we're going to say, okay, but it could also be this span. which is the 60 to 64. And that's going to be an OR. You're going to take this whole value, compute it to a true or false, and then you can OR it and say, or it is in this, it is equal to this span. So I'm going to put an OR, and let's just copy this. Snowball incoming. Big snowball. There. Okay, what's the next span? It's, it's 58 to 64. Yeah, 58 to 64. And then we got another span. Or, you thought I was getting really wacky when I was talking about if statements, right? No, I wasn't. It is wacky. 94. But yeah, snowball. I love it. 94. Oh no, 91 to 96. Or, and the next one is 123 and 127. Okay, bring on your gibberish. Bring it. Look at that. We're not debugging it. We're just going to roll with it. Okay, so is digit is special. So that means we just take this. Snowball. Number n digits. N special. Then we just take this. Again, snowball. N digits. Oh, I'm messing up. I'm messing up. Wrong. That's what I need. Because I got to compare for each possibility. It's only going to match in one, or it's not going to match in any, and it's going to be false. And therefore, then we don't count it. So this will be in special. Now we need to say, is digits here? You see how many is digits are already in there? That's where, let's rename this is digits. Just because we've got so many issues there. Okay, is digits, good. Then we got and special, good. Is special. All right, let's do more snowball. Cool. Now let's just test the special character. Okay, I'm going to put in less a greater than. This is checking all the different spans that we have. Every single one of them. Let's just see if they hit. Yes, number of specials is 3. We're good. Okay, you guys can play with debugging on some of that and kind of look into Mr. B's crazy if statement a little bit more. You know, just experiment by selecting different parts of it and see what it equals. Like select what happens between this OR and this group and this group. You can just select both of them, go all the way out to here. Oh my goodness, it's so far I can't do it. Okay, right there. Oh no. Okay, yeah, it's too much a pain in the butt to select them all. But you know, you can select just parts of it to see what it does. All right, so are we done? No, we got one more thing. Let's do a full test. Oh, no spaces. Oh crap, I put too many spaces. I messed it up. I got a little keyboard happy there. Okay, I think that's good. Last bit, guys. This is after all your testing's done. This is after all the code's been run. Prototypes. Now we're ready for release. Copy these. Put them down here. Go up here. Remove that. Remove that. Done. Remove that. Remove that. Done. So this is kind of the simplification, because somebody can just come in here, look at this code, just look at the very top and understand and have an idea of what the code does by just the function names. I can look at this code and I can say, oh, this is a ASCII counter, ASCII digit type, or ASCII character type counter. Good. You know, and then what we would expect to see, or what needed to be changed and whatnot. Okay, that's the full demo for you guys today. I don't think I forgot anything. I think we one last test. Okay, yeah. One last test. Yeah, I'm just gonna put stupid stuff in here. Good, done. All right, we're good, guys. Take care. I will see you next time.